So from Friday's assignment, any questions there? No others. Okay, explain to your neighbor how you can use your graphing calculator to find the maximum or minimum for number 3, or find the vertex, excuse me, for number 3, using your graphing calculator. Okay, so really quick, y equals, get it into y equals form, put it into your y equals menu. Go to calculate. In this case, since it opens upward, we know our vertex is a minimum. The other problem that was tough with this one was seeing where the zeros were. Okay. So let's go left bound, enter, right bound to the right of our minimum, enter, and then our guess, getting as close as we can. So looks like our minimum is negative, or is 0.208 and negative 2.5. Okay, so kind of a tough minimum there, a tough vertex. And then once again, if you want to calculate your zeros, you could do zoom. And I'm going to zoom box. I'm just going to kind of zoom into where the zeros are. You go to zoom box and put where you want the corner of your box to be. And just make sure you include the area that has those zeros in it. Hit enter. It gives you the opportunity to kind of zoom into where it's crossing the x-axis. And then you can calculate. So second trace, which is calculate our zeros, option 2. We go to left bound. So to the left of that 0, and then to the right of that 0, so it would be below it, and then a guess is as close to that 0 as possible. So one of my zeros is at negative 1/4, or negative 0.25, when y is 0. Remember, you'd want y to be 0, and then if I calculate my other 0, doing the same thing, go left bound to that, so to the left of this 0 right here, right bound up there, and calculate. It's negative 2/3, or excuse me, positive 2/3 0. Okay? A quick review on how to use the calculator there. Any other questions? Yeah, Emma? Yeah, so your quadratic went downward? Yeah, it won't change your zeros though, right? Yep. So solving wise, it won't change. It would just change it graphically. Yep. All right. Okay, let's go ahead and look at today's stuff. Our warm-up here, you guys have already kind of taken care of it, but explain what method you choose to solve each of the quadratic functions. Okay, what are the 3 methods? We talked about 2 last week. Graphing's 1. Good. Roots, or square roots, I guess we should call it. Square roots and factoring. And we didn't go into tons of factoring in terms of solving, but we have done factoring. Okay, so option A, what are we going to use? Square roots, factoring, or graphing? Square roots. How do we know to use square roots there? Good. We don't have a b term in there. So add 84 to both sides, you get x squared equals 84. I know it didn't say to solve, and then take the root, x is equal to plus minus root 84. And in simplest radical form, we can simplify that. That would be root positive negative root 4 times root 21, which is plus minus 2 root 21. Good. Okay? We want to put our cool little brackets around it. All right, how about option B? Is there any other way to solve that one? You could use other methods on A. Most efficient. Oh, you're saying another perfect one. Option B, factoring, graphing, or square root? Factoring? Graphing? Who says graphing? I hear both. Who says factoring? Okay, I'm going to probably use factoring. It's just quicker. It factors to x plus 4 and x plus 1, two things that multiply to make 4 and add to 5. Notice there's an a term of 1, so we don't have to deal with a there. What makes this part 0? Negative 4. What makes this equal 0? Negative 1. So my solutions are x equals negative 4 and negative 1. Okay? That was cat-like speed, I know. Yes. Okay? So once we have it down to this part where x plus 4 times x plus 1 equals 0, that means this or this has to be 0. That's the only way to get 0 when we're multiplying, is for one of those two things to be 0. Okay? This last one I'm using factoring here. I'm using square roots here. The last one I'm using graphing. Why am I using graphing? Because a is a gross fraction, yes. Okay. All right. Yep, it's the gross fraction. Okay, this one right here. Show your neighbor what you did. Okay, what do I do? Add 19. Okay, that's 0. 2 times x plus 3 quantity squared equals 32. And now what? Divide by 2. X plus 3 quantity squared is 16. Now what? Good. Take the square root. Do not multiply that out. Take the root of it. When I take the square root, that cancels the squared. Now I'm left with x plus 3. Then I take equals plus minus 4, right? You imposed a root. Subtract 3 from both sides. You end up negative 3 plus minus 4, which breaks into negative 3 plus 4, or 1. And negative 3 minus 4, which is negative 7. So break it into two different parts there at the end. Okay, so my solution, x equals negative 7, positive 1. Woohoo! So fun. All right, questions? Okay, here's what I'm going to have you do then. Since we seem to be amazing, let's give that a go. Number 7 through 10 in our monitoring progress. Continue with 3.1 here. Give it a shot. Let's start with 7 and 8 first. Okay, remember, two things that multiply to make 35 and add to 12 are 7 and 5. Okay, and then zero product property says that if I set this part equal to 0, what makes that 0? X has to be negative 7. Set this part equal to 0, what makes that 0? Negative 5. Okay, so our solution, x equals negative 7, negative 5. All right, number 8, what do I have to do first? Good, I have to get it by, got to get it all set equal to 0. 3x squared minus 5x minus 2 equals 0. Next step. Factor. So since there's an a term, remember you go a times c up here, which is negative 6. There's a, there's b, there's c. Recall from last week. What's this? This is our b term, so negative 5. Two things that multiply to make negative 6. Add to negative 5. Negative 6 and positive 1 and negative 6. Okay? 1 times negative 6, negative 6. 1 plus negative 6 is negative 5, so we put it into our sets. So x plus 1, x minus 6. And then what do we have to do? Divide by our a term, or 3, which is a step that a lot of people forget. Divide by a. This part reduces to 2, so we get x minus 2. And this part, since you can't reduce, jumps in front. 3x plus 1. Now, you have two sets multiplied to make 0. This part right here, if you say x minus 2 equals 0, that means x equals 2. And here, I'm going to actually show this one kind of up above here. 3x plus 1 equals 0. What are the two steps involved there? Subtract 1 and divide by 3. That is your answer. Okay, if you just state your steps, I'm going to subtract 1 and then divide by 3. That's your answer. Okay, so x equals negative 1/3 and 2. I'm waiting. Yes? Yep. Sure. Yeah, so, and that's a good point. So what Scarlett's saying is, hey, when I have x plus 1/3, I'm assuming, I think this is what you're saying. Can't I just say x plus 1/3? What makes that equal 0 is negative 1/3. Yeah, you could. The only reason I've made you jump through this hoop here is because as we progress, we're eventually going to have to take a quadratic and factor it and then cancel out quantities. So I want you practicing the factoring as well. But you're right, that would definitely be faster. Good. Any other questions there? Okay. Take a look at number 9. Find the zeros of the function. Theron. Sure, we could come up with some for you. Man.
Theron, this is your fault.
Wait, what?
Theron, you're scaring, dude. Man. All right. Find the zeros of the functions.
No.
So, what's a zero mean? Yeah. Yeah, 0 means x-intercepts. It means where does your graph cross the x-axis. Okay, so once again, if I think of my graph doing this kind of junk, well, first of all, I know my y-intercept is what? 0. It's the constant back there. So I know this graph's going to cross right there, which also kind of tells me one of my answers for x. What is one of those answers if I would have hit the 0? Should be at 0. It should be 0, 0. So we know 1, 0, 0. We want to find the other one if there is another one. So when f of x equals, so this is my f of x. When f of x equals 0, I'm going to solve for x. Can I factor that? Can I use square roots? Don't use your calculator. That's taking the long approach. You sure I can't factor that? Yeah, you could take out a greatest common factor. And x. X times what's x squared? And x times what's? Good. Hey, you factored it. You now have two things that are multiplying together. You took a greatest common factor out. That's the one thing you should do automatically every time. Okay? This times this equals 0. So if this part was 0, that would mean x equals 0. And if this part was 0, it would mean x minus 8 equals 0, which means x equals 8. So my solutions are 0 and 8. Yeah. Don't even need a calculator. Okay, give number 10 a go. Not a no solution. Man, this one's brutal. Like, the numbers are huge.
Not really.
I mean, 196 and 28.
It's not too bad.
And then two things that multiply to make 196.
14.
14.
And 14.
That's crazy. I mean, it would seem like It seemed like if there is a quicker way, that'd be nice.
I'm guessing there is.
I mean, you could, well, no, there's not a greatest common factor, unfortunately. I mean, we just have x plus 14 and x plus 14. Yeah, and then we could divide it by 4.
2x plus 7.
Becomes 7 halves. And 7 halves, so we get 2x, we got to move that out in front, plus 7. And 2x plus 7, which is just 2x plus 7 squared, but this part gives you 2x plus 7 equals 0 at minus 7 divided by 2, or negative 7 halves. And this is the same one, right? How many got it? Sorry. Well, you could have kept working. Hey, let's if you guys want to know the shortcut, this is a special type of quadratic. This is a perfect square binomial. Okay? That means this 2x plus 7, we could actually write this as 2x plus 7 quantity squared. Okay, and really when you're dealing with that, like if I'm looking at a quadratic and I ever note that the front is a perfect square and the back is a perfect square, I'm going to take the square root of that, 2x, and the square root of that, 7, and I'm going to ask myself, if I put that sign in the middle, 2 times 7 is 14, doubled is 28. If that's true, you're done factoring. 2x times 7 is 14, doubled is 28. Okay, those show up a lot, especially when you're going to vertex form. So those of you really paying attention and trying to take it in, that's going to be helpful to you in the long run. Because when you go from standard to vertex, if you can recognize right away that this is a perfect square, or when we do completing the square later in the chapter, it'll be important that you can recognize that as well. Yeah? That is right. Yep. That's not the answer. No. Okay. So this is my solution right here. All right. Yeah. This is a perfect square binomial. Yeah, this is a perfect square trinomial, and you can write it as, I'm sorry, this is a perfect square trinomial. This is a binomial square. We'll go through that later in the chapter. So I don't want to spend a lot of time on it right now, but it's a quick shortcut for those of you who have it down. Okay. I'd like to try this problem right here, number 6-a-roo. Oh, this one's fun, man. All right. So you have this egg that's being dropped during the science competition, and to prevent it from breaking, we want to figure out, or they've designed this container. Now, first you need to understand the formula or the equation that you can use to write the function that you need here. And that's actually, if you guys want to write it down, it's in your textbook. You don't have to use your book, but it's on the top of page 98. So if you want to read more about it, you can. But it's on the top of page 98. Your function is f of x Actually, we better use h of x, since they're using h. H of x is equal to negative 16 t squared. So it's not x, h of t. My goodness. I know. You got to pay attention. I'm not going to keep answering questions that I've already answered. H of t is equal to negative 16t squared plus h sub o. Where can you find that formula? Textbook, page 98. H of t is equal to negative 16t squared plus h sub o. So the next question generally is, what is h sub o? H sub o is your initial height. For those of you who are like, I don't know what initial means, except for my initials. Initial height means the beginning height, the starting height. Okay, sorry for the messiness, but there you go. You have everything you need now to part A, write a function that gives the height in feet of the container after t seconds, and how long does the container take to hit the ground, and then part B. So once you start with part A, work with your groupie there, you get a minute. How many have the function? Okay, so if I use h of t equals negative 16t squared plus, what's h of, or h sub o? 50. Okay, and so now, how long does it take the container to hit the ground? What's my height on the ground? 0. So h of t, this whole chunk becomes 0. So in other words, we're finding our t-intercept, or t-intercepts. However, it should only hit the ground once. Oh, I guess it could bounce. But, okay, but initially hitting the ground, so we subtract 50. And then we divide by negative 16. And then we take the square root. And when we take the square root, we have to go plus minus. And then the square root of 16 and the square root of 50, well, that's 50 over root 16. If you remember from back in the geo days or algebra days, root 16, this is perfect. That becomes 4, and root 50 becomes root 25 by root 2, which is 5 root 2. So t is actually plus minus 5 root 2 over 4. Now, what is wrong with that answer? You're saying your time is 5 root 2 over 4 seconds. Oops, 5 root 2 over 4 seconds. And negative 5 root 2 over 4 seconds. What's that, Derek? Yeah, you can't have a negative time, man. I'm not going back in time. Okay? All right, so 5 root 2 over 4, which is approximately how many seconds? 1.8? Okay. Okay. Any questions there? I'd like you to find and interpret h of 1 and minus h of 1.5. So find and interpret h of 1 minus h of 1.5. So you have to work together there, figure out what. All right. So it is a minus sign. However, you do them separately. So let's evaluate h of 1. So h of 1 is equal to negative 16 times 1 squared plus 50. Okay, that's this one. And this one is h of 1.5 is negative 16 times 1.5 squared plus 50. I'm kind of running into that other problem there, but all right. So when I evaluate this chunk, and I subtract it from this chunk, what is this chunk? 14. And what's this chunk? 34. And 34 minus 14 is 20. And height is measured in feet. 20 feet. So we found what it is. How do we interpret that answer? So hey, Haley, the common mistake here, for those of you who got it wrong, you got to square the 1 and then multiply by 16. Okay? If you square the 16 and then multiply by 1, that's how you did it wrong. Okay? So those of you who missed it, that's probably the mistake. Who made that mistake? Okay, a couple of us. Kai, what does it mean?
Between 1 and 1.5 seconds, that's how.
Good. Yeah, between 1 and 1.5 seconds, the egg travels 20 feet. Kai. Captain Kai. Wake her up. Okay. Very good. Questions? Make sure you interpret it. Between 1 and 1.5 feet, the egg travels 20, between 1 and 1.5 seconds, the egg travels 20 feet. Will it always travel 20 feet in a half a second? Okay, let me ask that again. Will the egg always travel 20 feet in a half a second? No, Ethan, why not? Why? She wants to pass. So if you don't care to pass, then you can sit there, but she wants to, so don't bother her. Okay? Between 1 and 1.5 seconds, the egg travels 20 feet. Will it always travel 20 feet in a half a second? Why not? Emma? It's exponential. It's not a linear relationship. It's an exponential relationship. It's a quadratic relationship in this case. Yeah. This is 1 second, and this is 1.5 seconds. So this is how far it traveled between 1 and 1.5 seconds. Correct. 1 and 1.5 seconds. Yeah. Okay, I'm going to hand out your assignment, but while I'm doing that, I want you to read over this problem right here. You have one like it on your test or on your assignment today.
Wait, are we solving it, or do you just want us to read?
Read over and kind of come up with a plan if you could. All right. Hey, you guys, it talks in this problem about maximum revenue. So first you have to have some context of what revenue means. Okay, how do you find revenue? It means like money brought in. Okay, if you're a magazine company, the way you're going to get your revenue, by selling magazines. Annual revenue is equal to the number of subscriptions times what? The price. All right, so if we use that kind of verbal model to do this, we could say our revenue is a function of our price X. And the number of subscribers we have, how many subscribers do they tell us we have? They say you start out with 48,000. However, they start doing some junk to those subscribers. Okay? That sounded disturbing, I know. But, okay? But I'm talking about, like, they start messing around with it up here, saying, hey, for our subscribers, we start losing subscribers. Okay? How do we lose subscribers? Yeah. Good. So when our price changes, we lose subscribers. Okay, so our original price is $20. But when it changes, so if we define X, remember X is our price, it's going to be our price increase. So if we can define X as our price increase, we could say, well, if it starts at $20, every time I increase, I have one price increase, I actually lose 2,000 subscribers per increase. So that's a rate. Now, dude, I mean, that's a good chunk there. It's saying, what is the maximum revenue? Whenever you see maximum, they're talking about a vertex. Okay? So if I kind of start manipulating this, I can move this around. I can call that, so I'm just going to move the things around in here. Negative 20 or 2,000x plus 48,000. Sheesh. X plus 20. They're having fun outside there. Okay? How many are still with me? Okay? Now looking at this, this doesn't need to be simplified, but I can take a number out of both of these two. I can take out what? 2,000. In fact, I could take negative 2,000. If I take negative 2,000 out of that, I get X. And negative 2,000 times what is 400 or 48,000? 24. Okay, and then I just keep my x plus 20 and bring it down. So does this parabola open up or down? Down. That's a good thing because we're looking for a maximum. Okay, we know that because a is negative. All right, and I could actually figure out what my, like if I multiply all this stuff out here, I could figure out my a term, or excuse me, my h term. Or I could think, hey, I could use vertex here. What's this x-intercept? 24, and what's this one? Negative 20. And the vertex is right in the middle, right? 24 and negative 20 is 4 divided by 2 is 2. That means if I was to graph this parabola, I'm just doing a really ugly sketch of it, okay?
McCoy, you need to get the paper.
Oh, thank you. Oh, I shouldn't do it there. Let's, if I did a really ugly sketch of this, I had negative 20 and 24. Here's 24. Here's negative 20. Here is 2. Okay? Now, when I want to find what is the maximum revenue, is that x or y? That's y. Well, the 2 represents x. How am I going to find my revenue? Plug in 2. Maybe plug it in there. Okay? When I do that, I end up with negative 2,000 times negative 22 times 22, or a really big number. That's a good revenue, man. Hook me up. Sheesh. All right. So a change from, if you change from $22 per subscription, you get a maximum revenue of $968. So how much would the magazine charge to maximize? $22. What is the revenue? $968,000. Well, you're not paying that for one magazine. That's craziness. That's crazy talk. Huh? Well, you wouldn't pay that for 12 months. That'd be a big subscription.